Hello, everyone, and happy Friday. Hopefully, you guys are set and ready to go for spring break. Hope everyone has safe travels that are traveling, and those of you who are still here, hopefully, you enjoy your sleep. Maeve, Noah, Josiah, happy birthday over break, and I will see everybody on Monday when we return after that break. As we go through our lesson today, there are going to be several moments where I do say, pause the video at this point, because if you look at our screen right now, you'll see that we have 2 vocab words to get written down, as well as a key concept. So I do want to make sure that we pause the video to give you a proper amount of time to get those recorded into your mini books. Once we're finished with our mini books, just like normal, you'll pass them to the middle aisle. They'll get collected, and then you have your activity that you're going to be completing, which is really looking specifically at what happens when we change the gases within our atmosphere. So let's go ahead and get started for today. For today, we're really focused on those changes to the atmosphere, the gases that are located within our atmosphere. So yesterday, we really looked at different ways that we could cause the ice to melt. We changed the amount of sunlight. Maybe you changed the reflectivity of the earth. But for today, we're going to focus on those 4 gases, the carbon dioxide, the methane, the sulfur dioxide, and the nitrogen dioxide or nitrogen oxide. So we're going to focus on those today to see whether or not they make a difference in our overall temperature and enough to make a difference in that ice. Our key concept that you should have gotten from yesterday was that if the global average temperature increases, then we know energy was absorbed by the surface. So you should have seen that the earth itself was starting to glow, which meant that energy was being absorbed by the surface itself. And then as a direct result, you would have seen those temperatures increasing. Go ahead and pause the video here so that students can get this key concept written down in your books. This should be going on page 2, box 2.
Please excuse us.
Okay, great. So now that that has gotten written down, we do have 2 vocabulary words to get recorded as well. Remember, if we're talking about this idea of energy being absorbed, let's remember what that definition is. So you're going to turn in your mini books to page 7, and we're going to be completing boxes 7 and 8 now. So box 7 is the word absorb. Remember, the word absorb means to take in. Please pause the video here for students to be able to record this vocabulary word. The next vocabulary word that you have is the word atmosphere. If we're going to be focusing on how changes to the atmosphere can impact the temperature or the ice melting, let's make sure we understand what atmosphere is. So this is going on page 7, box 8. The vocabulary word atmosphere, by definition, is a mixture of the gases surrounding a planet. Please pause the video here so that students can record this vocabulary word again on page 7, box 8. Now, when looking at our atmosphere here on Earth, the atmosphere is made of many gases. And so this includes the ones that are shown in the sim, the carbon dioxide, the methane, the sulfur dioxide, and the nitrogen dioxide. But then we also have oxygen, nitrogen, and water vapor all within our atmosphere. Now, we already wrote this down yesterday, but just to refresh your memory, we're focusing specifically in chapter 1 on why the ice on Earth's surface is melting. And so there's a lot of different reasons why scientists or climatologists believe that the ice is melting. We're going to focus today on our atmosphere. So our investigating question for today is those changes. What kinds of changes to the atmosphere could affect how much energy is absorbed by Earth's surface? So because the atmosphere is composed of several different gases, we're able to use the sim to change the amount of each gas to see what's going to happen to our atmosphere. Now, let's propose a claim. Let's actually focus on a claim so we can decide whether or not we support this claim, which means we agree with it, or if we're going to refute this claim, which means that we disagree with it. So if our question is what kinds of changes to the atmosphere could affect how much energy is absorbed by Earth's surface, let's propose this as an answer. A change to any gas in the atmosphere, both increasing or decreasing, could affect the energy absorbed by the surface in the same way. So it doesn't matter what we're doing to the gas, they're all going to affect the energy absorbed in the same way. In order to do this, you guys are going to be using the sim. So at this point, please pause the video and pass out the worksheet that goes along with the sim. Students, please remember you are not opening your computers yet. Please wait until the end of the instructions to actually go into the sim to complete the sim. While you are getting the papers passed out, go ahead and pass your mini books to the middle aisle so that they can be collected later in the class period. All right, great. So you should have just received a worksheet that looks like this: testing changes to the atmosphere. It says use the simulation to investigate the claim that all gases affect energy absorbed by the surface in the same way. While this says one partner is going to test, you will be completing both. Okay, so you're going to be completing both the front and the back side of this worksheet, as well as the summary questions at the end. One thing I really want to make note on is it does say to let the sim run for 20 seconds before beginning a test. Okay, so looking at our slide deck here, this will allow us to see the change easier. And the reason for that is it kind of allows the atmosphere to settle, and then you're able to see the changes that were actually made. Make sure as you complete your activities here, you are only changing one gas at a time, because if we change multiple ones, we've talked about this before, you're not going to know which one was actually causing the change. Make sure to leave all the other gases where they were. And when you are finished with each gas, either reset it back to its starting point or make sure you hit that reset button in the top right corner. When you click on the icon button, it actually shows you which one you're changing in the atmosphere. So the nitrogen dioxide is these purple circles. And in my picture here, you can see that there are purple circles. This will focus on the concept only one gas is tested at a time. If you're seeing multiple shapes appear, then you know that you're testing too many at once. Looking at the worksheet, it says you're going to start it, then you're going to let it run for 20, then you're going to run the test until it reaches 40 seconds. There are 3 different things that you're going to make observations about. You're going to make observations about the temperature, about the amount of ice, and the glow of that absorbed energy, right? Did that absorbed energy increase, decrease, or did not change? Looking at our slide deck again, you can go to the graphs where it's actually going to give you some numbers. You can see specifically that the changes are happening to the temperature or the surface ice or to the amount of energy based off this graph. Remember, looking at this amount of energy or absorbed energy line, we see those fluctuations, those highs and lows, but we want to focus on the trends. What is the general story of that line as you go through if you're making your decisions about increase, decrease, or did not change? You will do 2 tests for each gas. You're going to put it at its 2 extremes. You're going to test nitrogen dioxide at 500. Make your observations. Did it increase, decrease, or did not change each of the things? Then you'll put it at the other end of your scale and put it at 0. And again, make your observations. Each time resetting all the other gases back to their starting point and only changing one at a time. So when looking at your worksheet, you'll see here it says, when I increase nitrogen dioxide, we have 3 things: the energy absorbed by the surface, the temperature, and the amount of ice. You will simply check off increase, which means go up, decrease, which means go down, or did not change. Then you'll swing it the other way. Instead of at 500, you're going to have it at 0 because we decreased the nitrogen dioxide. Again, increase, decrease, or did not change. Once you're done with nitrogen dioxide, reset it. Put it back to its starting point, and then you'll do carbon dioxide all the way to the right, then all the way to the left. And then on the back side, you also have sulfur dioxide and methane. So you're going to run each of the 4 gases at their extremes, 500 and 0, and check off what each of those items did. Once you are finished testing each of the different gases, you're going to come back to those questions. Remember, our initial statement was that a change to any gas in the atmosphere affects the energy absorbed in the same way. Do you agree with that or disagree? And then make sure you provide evidence from your actual sim. Give specific details, not just because they were different or because they were the same. Once you are finished with this worksheet, you will turn it into the class tray, And then we will circle back to this when we return after spring break. If you have any questions, please see whoever's in the room helping you. Ms. Hubley will pop in every now and then. I hope you guys have a wonderful break, and I look forward to seeing you in April.